Hey guys, this next lesson begins the second half of this unit here. We're going to move away from expressions and talk more about equations and functions when dealing with radicals in this second half. And so we're going to start today with learning how to solve radical equations. A radical equation is just an equation that has a variable under the radical. Okay, so an equation that has a variable under the radical, or a variable with a fraction or decimal, otherwise known as rational, exponent. Okay, so it can look like an equation with a variable underneath the radical, or a variable that has a fraction or decimal exponent. Okay, so to solve radical equations, you're going to be able to read on your own kind of the steps I've outlined up here, but we're just going to jump right into number one, because I think it's easier if you just see me work an example. Your basic goal for these is to, first of all, get the radical part isolated. Okay, so the first thing I'm going to focus on is getting the entire radical here, radical 2x minus 3, by itself. And to do that, I'm just going to subtract 3 from both sides. Okay, so that's going to give me radical 2x minus 3 equals 5. Once you get the radical part by itself, then to undo a radical, you need to take the radical to the power of the index. Okay, so to undo a square root, we need to take both sides to the second power. So I'm going to do that. Squaring a square root will just cancel out the square root sign, so we're left with 2x minus 3 equals, and then we know 5 squared is equal to 25. Okay, so now we're just going to solve this like normal. This would give us 2x equals 28, and so x is equal to 14. One thing I have to do once I finish solving my radical equations is this last step here up in your box, step 5. When solving radical equations, there is the possibility for extraneous solutions. So you do have to check your answers when solving radical equations. So we do need to go back and plug in our solution to the original equation. So the original equation was 3 plus radical 2x minus 3. So I'll plug 14 in for my x. And see if I get a true statement. So this gives me radical 28 minus 3 underneath, which becomes radical 25. So we have 3 plus radical 25 equals 8. Radical 25 is just 5. So we have 3 plus 5, which does in fact equal 8. So that checks out, which means x equals 14 is a solution for this problem. Okay, let's look at number 2. Radical 4x plus 1 minus 5 equals 0. Again, I want to isolate the radical first, so I'm going to add 5 to both sides. And that's going to give me radical 4x plus 1 equals 5. Once the radical is isolated, then we're going to square both sides. So here and here square. That's going to give me 4x plus 1 equals 25. Now when I solve this one for x, subtract 1, I get 4x equals 24, and then x would be equal to 6. Again, I want to check my answer just to be safe. So we're going to check the radical of 4 times 6 plus 1. Subtract 5 equals 0. This is going to give me radical 25 minus 5 equals 0. Radical 25 is just 5. So we get 5 minus 5 equals 0. And in fact, 5 minus 5 is equal to 0. So this one does check out. So we can say our answer is x equals 6. Okay, moving on to number 3. we have radical x plus 7 minus 5 equals x. So I'm going to try to isolate radical x plus 7 first of all. That means I'm going to add 5 to both sides. So I get radical x plus 7 equals x plus 5. Okay, now I'm going to go ahead and square both sides. And when you're squaring, make sure you square the entire quantity on the right side, the quantity x plus 5. So what we end up getting is, on the left side, just x plus 7. On the right side, we're going to have to do a little bit of foiling, because when you square a binomial, you have to think about it as x plus 5 times itself. So this actually gives us x squared plus 10x plus 25. Okay, and then from there we can see we have a quadratic equation. We're all experts at solving quadratic equations now. We need a set equal to 0. So when I set this equal to 0, it's going to be 0 equals x squared plus 9x plus 18. And then from there we can see that that easily factors. That factors into the quantity x plus 6 times the quantity x plus 3. And so that means x would be equal to negative 6 or negative 3. Again, we must go back through and check those answers here. So we do need to check both of them. Let's go ahead and check negative 6 first of all. Okay, so we're putting in a negative 6 for x in both spots. So radical negative 6 plus 7 subtract 5 equals negative 6. Okay, well the square root, or negative 6 plus 7 is 1, so we get radical 1 minus 5 equals negative 6. Radical 1 is just 1, so we get 1 minus 5 equals negative 6. And here is a really good example of why it's very important to check. 1 minus 5 is equal to negative 4, which is not equal to negative 6. Okay, so this is a false statement here, and that means that negative 6 is not a solution to our problem. It's actually extraneous. So we're not going to include it in our final answer. I now need to check my other solution that I got, negative 3, to make sure it's also not extraneous. If it is extraneous, then this would just be a no solution problem. So we'll check it the same way. Negative 3 plus 7 under the radical. Minus 5, set that equal to negative 3. Negative 3 plus 7 is 4. So I have radical 4 minus 5 equals negative 3. Radical 4 is just 2. So we get 2 minus 5 equals negative 3. 2 minus 5 is indeed negative 3. So this one here checks out. Okay, so that means that my only answer to this problem is negative 3. Okay, number 4, this one doesn't look like at first glance a radical equation, but it really is. Okay, remember the definition of a radical equation is any equation that either has a variable under the radical or a variable with a fraction decimal exponent. This one does have a variable inside a group of parentheses that it has a fraction exponent. The 1/2 power, you remember from the last couple of videos, means the same thing as the square root of. So 5x minus 1 to the 1/2 is the same thing as radical 5x minus 1. So this is still a radical equation in disguise. So we're still going to focus on isolating this part right here. So that means I need to subtract 3 from both sides. And that gives me 5x minus 1 to the 1/2 power equals x minus 3. What I'm going to do now is the same thing I did for the last problems. I'm going to take both sides, because this is really a radical in disguise, to the second power. And you'll see how that works when I'm writing this in exponents format. When you take a power to a power, you multiply the exponents. So if I take 1/2 here times 2, they just cancel each other out, and I get 5x minus 1 to the first power. Okay, so it works the same way, and it actually makes a little bit more sense when it's written as a fraction exponent. You see that those exponents cancel each other out. That's why the radical cancels when you square it, okay, for all the other problems. So you get just 5x minus 1 over here equals, we're going to have to square this binomial again. X minus 3 quantity squared is going to be x squared minus 6x plus 9. and so we get another quadratic for this one. I'm going to set it equal to 0, and so once I do that, I get x squared minus 11x plus 10. And from there I can see that, again, I factor pretty easily. This factors into x minus 10 times the quantity x minus 1. And so that means that x is going to be equal to either positive 10 or positive 1 unless we have extraneous solutions. Okay, so what I'd like you to do right now is I'd like you to write out the checks for both 10 and 1 and see if they both work, if only one of them works, or if this is a no solution problem. So pause the video. This means you gabs. And once you have checked those and written it out, click play to check and see if you're right. Okay, so this problem, just like the last one, we actually get one answer that works, one that doesn't. When I check positive 10, it does check out and I get 10 equals 10. So that one would be a solution. When I check positive 1, though, I end up getting 5 equals 1, which is false. And so x equals 1 would be an extraneous solution. So the only solution we'll include in our answer is positive 10. Okay, last couple of examples. In these examples, you're going to notice that there are 2 radicals per problem. So whenever you have 2 radicals per problem, you want to focus on isolating the most complicated looking radical first. So for number 5 here, I have radical 2x plus 1 minus radical x equals 1. The more complicated or lengthy radical is the first one, radical 2x plus 1. So I'm just going to focus on isolating that one first. So that means I'm going to add radical x to both sides. And so that's going to give me radical 2x plus 1 equals radical x plus 1. And so now I'm going to square both sides to get rid of this radical on the left side. Again, I have to keep in mind that I have a binomial here on the right side, so I'm going to have to do some foiling, okay, to square that. Left side, I just get 2x plus 1. On the right side, let's actually write this out so you can see how this works. Radical x plus 1 times itself is going to give me the following. Radical x times radical x is just x. Radical x times 1 is radical x, so I have a plus radical x. I have another plus radical x from the inner terms, and then finally 1 times 1 is just 1. So I end up getting x plus 2 radical x plus 1 when I square this binomial over here on the right side. Okay, so what I'm going to do now is, because I still have a radical in my problem, I'm going to work on isolating that radical. Okay, so I'm going to subtract this x and this 1 from both sides, which gives me just x on the left side equals, and we're left with 2 radical x on the right side. And then to finish up isolating this radical x, I need to divide both sides by 2. So I end up getting, I'm going to move over here, x over 2 equals radical x. So now I can get rid of my last radical by again squaring both sides. This will give me x squared over 4 equals x. And now at this point, some of you might be stuck and wonder what to do from here. Well, keep in mind this is nothing more than a proportion. We have x squared divided by 4 equals x divided by 1. So proportions, you can cross multiply. So if I cross multiply here, I just get x squared equals here 4x. Okay, and now you'll see we have a quadratic equation, and we can set that quadratic equation equal to 0 by subtracting this 4x from both sides. Okay, so a lot of algebra that we've learned in the past is going to be applied to these radical equations here. You need to make sure you understand how to solve a quadratic equation, how to solve a proportion, etc. So x squared minus 4x equals 0. I can factor an x out of that, and I just get x times the quantity x minus 4 equals 0, which tells me that my 2 potential answers here are x equals 0 and x equals 4. Okay. For the sake of time, I'm not going to write out the checks here. I want you to do that on your own for me, though. So I'm going to go ahead and click pause, have you write out the checks either somewhere in the margin here or on a separate sheet of paper. And once you have those, click play to check and see if you have the correct answers. Do that now for me, please. Okay, if you did that correctly, you should have found that they both actually end up working. X equals 0 is a solution, as is x equals 4. So this is one problem where there are two solutions, 0 and 4. Okay, last one, number 6. We have radical 5x plus 4 minus radical x equals 4. Same thing as number 5. I'm going to isolate the more complicated looking radical first. And so I need to add radical x to both sides, which is going to give me radical 5x plus 4 equals radical x plus 4. From there, I'm going to square both sides, which is going to give me 5x plus 4 on the left side equals, the right side is going to behave similarly to how number 5 did. Okay, we're going to get x plus 8 radical x plus 16 if you FOIL that out. Okay, so now your job is to get the other radical that's left over isolated. So that means we need to subtract x and 16 from both sides. And when I do that, I get 4x minus 12 equals 8 radical x. Okay, from there, unlike number 5, I'm not going to divide both sides by 8, simply because if I do that, I'm going to get some fractions on the left side. Okay, if you divide 4 by 8, you're going to get a 1/2. 12 by 8, you're going to get a 3/2, and it's not necessarily a terrible thing, but I don't like to deal with fractions when I can avoid it, so I can actually square both sides from here. And again, this is simply to avoid having fractions in my problem. So if I square both sides from here, it's still going to get rid of the radical, okay, because on the, let's do the right side first. On the right side, when you square 8 radical x, you get 64 times x. 8 squared is 64, radical x squared is just x. Okay, so my goal is still accomplished. I still get the radical part disappearing. On the left side, 4x minus 12 quantity squared, if you multiply this out, you're going to get 16x squared minus 96x plus 144. Okay, so now we have another quadratic here. I can subtract 64x from both sides and get 16x squared minus 160x plus. And now we have a quadratic equation that looks kind of terrible, but if we're smart, we're going to look for GCFs. I know that 16 goes into 160. I'm not sure if it goes into 144, but that's what a basic calculator is for. If you try 144 divided by 16, you can see that it does go into 144, and so that means if I move up here, I can actually factor out a 16 from everything. So I get 16 times the quantity x squared minus 10x plus 9 equals 0. Okay, if I divide both sides by 16, that gives me just x squared minus 10x plus 9 equals 0. And so now I can factor that very easily. That factors into x minus 9 times the quantity x minus 1 equals 0. And you get x equals positive 1, x equals positive 9 as your potential solutions. Go ahead and one more time pause the video for me, check to see which of those, if any, are extraneous, and once you do that, click play one more time just to check and see if you got that right. Okay, and if you checked correctly and found the extraneous solutions correctly, you should have found that 1 is extraneous, so it is not a solution. 9, however, is. Okay, so the only solution for this problem is positive 9. Alright, as always, if you have any questions, be sure to jot those down or just email them to me ahead of time so I can address those the next time I see you in class. And until that time, have a nice day. You are all wonderful people. Take care.